Welcome back to Uncle Fish. Today we're going to talk about functions in C++. Functions is a big topic, so we're going to break this into two separate videos. The first video, this one, we will focus on the lecture aspect of things. And in the second video, we're going to focus much more on the code aspect of things, right, on functions. All right, so disregard like what you see on the screen here for now. We'll be talking about that in a second. But let's first start by describing what a function is, right? So to understand a function, think of this block of code, okay, where you have some kind of an input, potentially. You do something, you perform some action, some task, and you may or may not, but have some kind of an output or a result or something, right? And that's essentially it. That's basically what a function is. And for those of you that have been learning C++ with us, you've already seen functions in action, because the most popular function of all is the main function. And you've seen this over and over again, ad nauseum at this point, right? And if you've also been following along, you've likely seen that when we started learning C++, we have started with a couple of statements in here, some print statements. And then over time, as the videos went on, when we learned vectors and strings and all sorts of other things, something interesting started to happen to the code samples that we were using. What started to happen was this main function started to get bloated, right? So imagine that each one of these lines that I'm drawing is some command, right? Started to get bloated in the sense that we were packing in all sorts of different things into our main function, because our entire program basically was contained inside of this main function. So you might be wondering, like, okay, so what? Like, all those code, all those examples that we wrote, they all ran, they all didn't have a problem. So what's the issue? I'm going to write my next program and I'm going to lump everything into main again and be happy, right? Well, you can certainly do that. There is a challenge, though, that you're going to face over time as this becomes, bigger and bigger and bigger. As this increases, things start to become harder for you over time. So what becomes harder for you? Debugging becomes harder for you. When you have a problem in this code, it's going to be really difficult to figure out where exactly that problem is happening and what's causing it, because you have so many different actions and some of them that are like not really related to each other, right? But they're all thrown into here. Once you find where it is that you have the problem, let's say like it's right here and you found this problem, how do you test it, right? You have this challenge with like, now, I don't want to run this whole thing just to test this one particular thing. And so I want to be able to kind of just focus in on this and fix this. And it's really more difficult to do that when you have everything bundled into one place, right? What about repeatability, things that I'm doing kind of over and over again? Could I reuse some of my code? Like, why do I have duplicates? And there's a really high chance, right, when you do things like this, that maybe you had some function over here where you were adding something, not function, but statement where you were adding something, and then down here you're adding again, but you're not really reusing anything. You're just kind of repeating code over and over and over again, essentially, and not taking advantage of reuse, right? Overall, like, maintainability of this code becomes really hard. So over time, you might want to add features and take features away. It's really difficult now. Where do you put it, right? You want to make sure you didn't break something else, like as you added new things. So these are like some of the basic benefits, really, of taking your code and putting it into functions, right? You essentially are building like tiny modules using those functions. And then you can reuse those modules. You can test those modules easily, right? If you have a bug, you can focus in on just that particular module and fix whatever bug you might need or need to fix. If you need to enhance the code, it becomes a lot easier, because you can then go and focus in on those tiny modules instead of one big blob, right? And there's a very good chance, right, that you're not going to be working for a company of one, where you're writing everything and you're the only employee, right? So you're going to be working with a team of people. And so this notion of like reusability and sharing code across packages and libraries, right, becomes really important. And so you leveraging functions is a really important and key way to go do that. Now, there's a bunch of other benefits that are out of the scope of this discussion. We'll talk about those kinds of things later, but when we get into classes and we talk about things like abstraction and encapsulation and all of those things, that's for another time. At this point, just try to focus in on like, what are these functions and how do I start to organize my code, right, in a better way. That's a really good way to think of it, is how do I organize this blob here into some more manageable and reusable way. All right, and that's where functions are great. So that's how we're gonna kind of go into the next section here to describe them, but that's the benefits and why you would want to use them. All right, so let's talk about what are the parts of a function. And again, you've already seen this. Yeah, if you've seen it, main, you've seen functions. But let's take a different example. Again, another basic example, and we'll talk about what are some of the parts. So here's a really basic example, that one that I'm moving my cursor over here. So let's write over this and figure out what exactly the parameters, the parts of the function are. All right, so this first guy here, this is your return type. Okay, and basically what this is telling the system is whenever this guy finishes, whatever's going on here, the caller expects to get an int back, right? And that's it, okay? And so this guy here is the name of the function. We call this add in this particular context. What's happening inside of these parentheses here, this is known as your inputs, or as a parameter list. That is an A param list. Okay, and then here is your kind of return statement. Right? When the function finishes, what happens, right? So in this particular case, I'm going to return basically what A plus B is, since this is an add function. And this whole thing here is your function body. So remember, this is a really basic example. You can do lots of other things inside the same function, just like similar to what we were doing in main, right? Not recommending that, I'm just saying that from an example perspective. All right, so these are the different parts of the function, and we can call this particular function. So let's say if you're an int main and you wanted to go call this guy, how would you do that? Right? Oops, sorry, let me erase that real quick. How would you call this guy, right? So you could say, int x equals 1, int y equals 2, and then you could say basically sum, or int sum is equal to add x and y. Right? That's a basic way to think about how you're going to call that particular function. All right, so we've learned now what how the syntax kind of looks like, right? We've looked at now what are the different parts of the function. We're going to now take this apart a little bit and get a little bit into what is happening under the covers when you call these functions and how these functions are stored. Now, in order to do that, what we're going to do is take a little bit of a tangent and describe what your program essentially looks like when it's running under the covers. We won't spend a lot of time on this, but again, it's really important to kind of at least get an understanding here. So what we have here is a CPU and the central processing unit on your computer. This guy is basically fetching instructions and executing them. Okay, and instructions is your code. It's your compiled code, right? And compiled, remember, is machine, down to the machine code in C++, down to the ones and zeros. Where is it getting this stuff from? Who is it interacting with, right? It interacts with memory. Your program is running in a place in memory, and your program is allocated specific areas of memory, right? So let's go over what those areas are. Now, I'm going to do my best here to draw a straight line, but I'm so bad at this. All right, that was not bad. All right, I'm going to try to draw another one straight. Come on. Oh, man. All right, not good. Close enough though. So let's break some of these things down. So one segment of memory is the text segment. Another segment of memory is a data segment. I'll kind of draw this a little bit bigger and put a dotted line in here because it's actually broken down into two segments. There's like an initialized segment and then an uninitialized. Out of the scope of this discussion, okay, but we'll do a video later on, like anyway, going into more detail of these things, but not for now. You have the heap section, and then finally you have this stack section. Okay, we'll go through now each pieces here to kind of tell you what's happening here. So inside the text segment, this is where your code lives. It's also called the code segment. So this is where your compiled code is. This is the instructions basically, right? That's kind of going back and forth on what to do next. This is read only typically for obvious reasons. Like you compile the code, you're running the code, it's the instructions. You don't want something to change the instruction. There's all sorts of problems when that happens. Your data is where things like global variables and static variables, static meaning unchanging variables, which to me is an oxymoron. Right? So this is where these things are stored. The heap, this is where, think of this as kind of like the big blob of space, your dynamic area of memory. So when we talked about in previous videos like vectors and other data structures, this is where those things were being allocated inside of the heap. And then we have this stack, right? And the stack is again another data structure, but why we're talking about it here is because your function calls are stored on this particular stack in frames. All right, and we're going to go over examples of what that looks like, but it's good to get this like at least foundational understanding here of what's going on under the covers, because it will really make like some of the other things we're going to talk about, like pass by value, pass by reference, and things like that, a lot easier to understand. All right, now let's go and erase this, and we will go back to the parts of the function and what's going on in memory. All right, let me see if I can get this other, I accidentally erased over this guy. Let me see if I can get him back. All right, I'll get him back and put him on top. I accidentally erased him. All right, sorry about that. And let's just save this first. Let's add a new layer so we don't do that again, okay? All right. Okay, so we've talked about the parts of a function. We've talked about like how to call it, right? You kind of know the basic syntax of the function. So let's go a little bit under the covers here and see what exactly is going on in memory, all right? So we'll go back to this guy and describe it. So we talked about the return type, right? Int. So the return type in this particular case, like why are we telling it that it's int? Why is it even important? Well, it's important because we need to tell the system that, hey, you need to go off and you need to reserve for me some space. That once I finish this particular function, I'm going to give you some value and I'm going to put it into here. Hence why the data type is important here. So in this particular case, like I mentioned in previous videos, like int is typically like 32 bits. So this is telling the system, hey, reserve for me 32 bits that after, if anyone calls this function, once it finishes, I'm going to need space to return a value, essentially, okay? The function name here, add. So let me erase this again. We'll go down to add. So add was the function name. And so what's kind of happening with add, right? So add is actually stored in something called a symbol table. And we're going to use that term again and again, but basically the symbol table is a fancy word for saying that the word add or the symbol add is actually references this some spot, some memory address, and say 0, 1, 2, 3 or something like that, right? Some place in memory is where the name is going to associate with. And we'll talk about exactly what that points to here in a second. But just for now, that's where the function name is. And the symbol table itself is this data structure that is maintained by the compiler. Again, this maps like variable names and function names to the corresponding memory addresses. So when a function is called, that name is then resolved to its memory address. And when the value is brought back, it is actually going to go and jump to the code of that function, in this particular case, the function body, okay? But we'll touch upon that here in a second. So that's what's happening with add, right? All right. The next spot that we're going to talk about is the parameter list, this int a and b, right? So what's happening with these two things? So first and foremost, let's think about from a storage perspective. So when that function is called, each parameter here, a and b, is actually stored on the stack frame. So in the stack frame, you will see something, right, that says, again, how much space do you think it's going to reserve? Well, we told it it's int, right? So it's going to have some spot of 32-bit for A, for this guy, and then some spot of 32-bit of B, for B, right? And so this is then going to get placed onto the stack frame. And then when inside of the function body, you notice here, right, we're saying return A and B. We're actually referencing these local variables, right? So inside the function body, these parameters then access using those names. And again, we use the symbol tables. Just like before, and in that symbol table, you'll see something that says A and B, and it equals to some address. But in this case, where do you think the address is going to be? It'll be the address that's on the stack frame in memory. Okay, hope that makes sense. Same as here. I apologize for my bad writing. All right, so that's what's happening there from a parameter list perspective. Lastly, well, almost lastly, we will look at what's happening on this, right? So remember, we said that this entire thing was your function body. Okay, so now this guy, from a storage perspective, this is stored, where do you think? It is stored in the text segment, as we mentioned earlier, right? Hopefully this is all making sense now. This was the text segment or the code segment. This was read-only. This is where it's stored basically in machine code, right? And this is what the CPU is kind of going back and forth with to get its next set of actions and things that it has to go do. All right? Now, why am I going over all of these things? Well, when you're talking or when you're working with functions, one of the things that you're going to run into and you're going to need to learn without question is going to be this notion of a pass by reference versus pass by value. Okay, and this trips up students more than probably anything else with respect to functions. So let's first talk about pass by value. Okay, so we're going to look at this particular guy here. So imagine that we had a main function. So in our main function, we're going to say int, I'm not going to write it all out, the proper syntax, we're just going to use pseudocode, okay? So we're going to say x is equal to 5 and y is equal to 10. And then what we're going to do is we're going to call this function add. And we're going to say add x and y, right? All right, so what do you think is happening here, right? We talked about the stack frame, right? So on the function call for add, there will be a stack frame now that says, hey, I need to allocate O, or A, sorry. So here's our stack frame again, right? It's going to say I need to allocate A, and I'm going to put A. What value is A going to get? Well, A is mapping to whatever they passed me in here in X. So what did X map to? X mapped to 5, right? So A in my stack frame is going to equal to 5. B in my stack frame is going to equal to 10, right? Because 10 was passed in as Y. And that's what my function is looking at for the second parameter, right? So this is how it's going to look, right? All right, great. So if I were to, after this add, say cout x, what do you think will be printed, right? So what should be printed is 5 because you passed the value into the add function. You did not pass x, right? You passed the value of x in this particular case. And so you passed it 5, and so it's going to add 5. 5 plus 10, or 5 plus 10 is 15, and that's your answer, okay? But x itself, it wasn't really touched, right? So this is the default way that you typically will interact with functions, and this is pass by value, all right? Hope that makes sense. Let's go look at now what a pass by reference would look like. Right? So that's pass by value. All right, now, pass by reference is a little different, right? So we'll take the same here, this example now. So notice again here, I'm doing something just for example purposes. I'm saying void. Void, remember, meant that's my return type. This function is not returning anything, right? This was the return type. So there's no return type. Notice there's no return statement, right? So hopefully that makes sense. So there's nothing to reserve. There's no end coming back. There's nothing, right? Notice also that we have this new syntax here with this ampersand. So int ampersand A and int ampersand B. So this ampersand is what is dictating. It sounds funny when I say ampersand. I don't know why. But this ampersand is what is dictating the pass by reference. All right, so let's go see what's happening in this particular case. So again, we'll go into like our pseudocode in main. And then let's say that I am, in this particular case, going to say the same thing, right? Add, this time by reference, right? Oh, sorry, let's make our x and y. So we'll say x was what? Like I think we said 5, right? Y was 10, let's do that. All right, so now we're gonna pass it by reference. And by pass by reference, we're again gonna pass it x and y, all right? So when you pass it by reference, what do you think the stack frame is gonna look like for this function add by reference? So again, it's going to do what? It's going to allocate local variable A. What is it going to equal? Remember, in this case, it equaled to 5. But pass by reference is not passing you 5. What pass by reference is passing you is the memory address of X. That's the difference, okay? And then local B is passing you the memory address of Y. Oops. Right? So what's going to happen, right? So A, it's saying that A, what's A here? A is where the memory address of X was, right? So think about it like this. So if I had in memory, some spot that said X equals to this thing, whatever that is, and Y equals to this particular thing, right? When we were doing pass by value, we were taking what was in the bucket here and passing it. But in this case, we're passing it this, not really what's in the bucket, right? So what's happening in this function is it's saying, hey, take A and add it to B, right? Okay, great. So what it's going to do is say A plus or equal to B. So A plus or equal to B. So it's setting what is in this bucket to the sum of what's in this bucket and in Y. So what was added to both of those things. So what was in X to begin with? It was 5 and 10, right? But pass by reference, again, is passing the memory address. So if I were to do a C out here and say C out X, what do you think is going to happen? Before, with pass by value, X was unchanged because we just passed a 5. But here we're actually passing the memory address. So what's going to actually happen is that C out X is going to be 15 because we passed it the reference, right? In the stack frame, we said, hey, your A is really equal to what is in this bucket of X with this memory address of X. And your B is what is this memory address of Y. And I'm saying set A to plus equal, meaning set A equal to A plus B, right? That's what that means, right? So A is equal to A plus B. So it says, oh, okay, cool. So I'm going to take the memory address of A, well, that's X. So it goes to X and says, hey, get me this. What is it? It's 5. All right, cool. So get this, give me what Y is. It's 10. Add the two together and store it in X because that's all he knows, the reference value. And that's the difference, right? So hopefully that makes sense of what the difference is between pass by value versus pass by reference. And you may be thinking like, I don't know why I took C++. Maybe that's what you're thinking. I hope not. But if you are thinking like, okay, yeah, that makes sense, but like I don't know why I would ever want to use something like this, right? Well, so if you think about a more realistic example, imagine that in this particular case, you wanted to, parse through and modify a list, right? Let's say that you wanted to pass like a list of, 1 million records of something, 1 million records. And you wanted to add all of them, I don't know, right? Something like that. What's happened with pass by value, you saw, right? We were copying what was in X and we copied it over to A. There was some kind of copy, right, that happened, and then some addition. The pass by reference, there was no copy. We were passing the actual reference of X, that address, right? So if you had 1 million records and you wanted to do pass by value, you're literally going to go copy those 1 million records from wherever they were to this new location, right? So that that particular function can go interact with them. That seems really like not performant, right? So it's not efficient in this particular case. So when you have larger data structures, you may want to just pass it by reference instead so that it can go modify that data structure as is instead of copying it to its local stack frame and its local variable, right? And then doing that particular thing, right? There may be other things, for example, that like consistency with older like C style APIs. Many of those older APIs use pointers and references. So passing by reference is going to help you understand how those older APIs worked. If you want to, like, again, modify the original data, kind of like in this same example of like not wanting to do the copy, but you have this big thing and you want to go in and just modify the original things, then passing by reference is going to allow for you to go do that, right? Another possible purpose, right, by using pass by reference is if you wanted to return multiple results. So if a function needs to return multiple values, you want to pass the values or variables by reference. This is going to allow that function to update those variables directly without needing some, complex return type, right? You can go off and do those things and then you know exactly what the result is because that function is doing it for you. All right. So again, this typically will confuse students. So hopefully this made it a little bit more clear as to like what's going on. Some of the worst bugs that we see are a misunderstanding of passing by reference versus passing by value. So I hope that makes sense. All right, now we are going to get to the last section here of functions, which is function declarations, right? So you've seen these functions here. How do you declare the function? How do you tell the compiler that you have a particular function? So thus far, what we've seen is, I'll take example, let's say that this is the top of your code, right? And we say we have something down here in main, right? And then we can call that particular function, like add, whatever. You're allowed to do this. Let's say that this was your whole code file right here, this whole thing, right? You're allowed to do this because to the compiler, which reads the file like this, I told you I was bad at straight lines, it saw the definition of this function already. So it sees what to do here before you called it. So this is allowed. There's no real reason for you to have to declare the function, right? Because it knows about it. Now, if you did the opposite though, let's say in that same code, you had your function at the bottom of the code and you had your main function up here and you said main, right? And you wanted to call add. This would not work because again, we're reading it top down. And when the compiler sees main first, and he says, "Hey, you're calling this add thing. I never saw an add. I don't know what it is. How can I compile for it?" Right? So you either have a choice here, right? You can say, "Hey, I'm going to always put all of my function declarations up at the top, right? And I'm going to always keep my main code, kind of at the bottom." Sure, you can absolutely take that approach, but a better approach, right, is to actually use like what you would commonly see inside of your program that you're going to likely see at work and such like this, right? Like more standardized, right? So the more standard way, whoops, sorry, let me erase this. So the more standard way to do this is to declare the function, right? So what do we mean by the declaring of the function? So a declaration of the function is really something pretty simple. You're basically declaring the signature of the function, right? So what is the signature of the function? If you looked at this particular thing, the signature of this would just be the return. You're kind of basically just trying to describe to the compiler the critical points about the function that it needs so that it can plan for it, right? So you're going to say that I want the return type, you may want the name, and you want the parameter list. Semicolon, and that's it. So in our example here for add, it would be int add, open parentheses, int A, int B, semicolon. That's it. So this is your signature for the function, and this is the declaration. So if you do this, then you can put typically at the top of the code, like if you had one file, you would write this at the top of the code, and all of your functions signatures would be declared, and then later you could go off and define the actual function bodies and all of those things. Now again, even this is not really what you're going to go see in the real world. In the real world, what you're going to see is these function declarations are actually stored in what are known as header files. Okay? Header files are literally like you'll see .h. So for example, if I had some code called functions, functions.cpp, I would have a corresponding functions.h file. And in that h file would be where all my signatures are, right? For the functions that are in CPP. Again, if you can get a little confused by this, this will make a whole lot more sense when you get into object-oriented programming and you get into encapsulation and some of the other more advanced topics. But for right now, this is, again, just think about it from an organization perspective, right? You've modularized your functions. You can also put those signatures into the header file. This allows for other developers that want to go use this particular function, they can go look at the signatures in just a header file and get an idea of, hey, how do I interact? What do I need to pass in? What am I going to get back, right? So it's a simple way for developers to also know that. So the header file has a format, something like this. It'll say if, in, def, right? I don't know, functions, header, and then define it, and I'll go over what these mean, right? So then define function header, right? And then it'll have all my declarations or signatures in here, okay? And then it'll end this if at the end. I'll say end if, and that's it. So what does that mean, right? Well, so the parts of this really are basic. The names look really cryptic, but it's not. Sorry, I keep losing the screen here. So what's happening here, right, is this if and def. So this means if not defined. This checks basically if this particular header or this specific code has already been instantiated somewhere in memory. So for example, imagine if you have lots of developers and they were all using this functions file, this function CPP, or this function code. You don't want this to be instantiated again and again and again and again, right? So basically what this is saying is, hey, if this has been defined, if this headers have already been defined, if not defined, if and def, then define it. That's the next one, right? So it's just basically an if-else statement or with no else. So if it's there, then define it. Okay, here's how I'm going to define it. I will give you all the content and the declarations, and then I end the if. All right? And so that's pretty much it when it comes to functions. I know this was a little bit of a more complicated video. When we go over some of the code stuff, I hope that will kind of complete the picture for everyone. I try to end with a joke with this, but I was really having difficulty in coming up with a joke for functions. I even tried to write a function for it to kind of tell me a joke, but unfortunately the return type for that function was void. You get it? Void has no return type. All right. Thanks a lot for listening. I hope you enjoy, and stay tuned for the next video, part 2, where we're going to look at the code directly.